So welcome to Effective Android Data Binding. My name's Eric, and I'm a product engineer at Realm. And most of this talk is going to be talking through experiences that I've had working with data binding in production applications. One thing to keep in mind is I'm both an Android and iOS developer. I don't know exactly how that plays into this talk, but I feel like I have a unique perspective a lot of times, being able to see how both sides solve the same types of problems. One thing I just want to apologize if you thought you were coming to Effective Android DAT. This is not that, this is data binding. It was pointed out to me that, thank you. It was pointed out to me that on the app, the ADA binding part of it got truncated off somehow. All right, so what to expect today? I'm going to start off assuming you don't know anything about Android data binding. So if you're totally new to the topic, this will be great. We'll cover some pretty simple examples on how to get started using it. Even if you've used data binding a little bit in your apps, hopefully some of the features I go over are maybe some new features that you didn't know about. I'll also talk about, based on my experience working with data binding in an MVVM architecture or model view model architecture, how those two things play nicely together. And at the end of it, we'll look at just some experimentation that I've done working with view models and LiveData and how that can play in with data binding. And I'll leave you with some tips based on observations I've made working with building data binding applications in production. So I'm a big learner by example. And so when I give presentations or try to teach material, I always try to build samples that you can reference later so that you can kind of cement that material that I've talked through in slides and also build on that. So if you go out to my GitHub page at Eric Maxwell 2003 and you look at the data binding demos project, clone that. It has basically 4 modules that everything I'm going to talk about today is built off of. So I start out with a very simple introductory. This is kind of the vanilla, how do you get started with data binding? But I also have like this login form example that shows how you might use it with LiveData and view models and how you can use two-way data binding. I have a recycler view example and then just kind of a kitchen sink that shows off a lot of other things. Okay, first a quick introduction. If you've never used data binding before, really all this is a support library from Google that allows you to bind data directly to your views. You don't have to find these views by ID and set the values of, say, text fields and everything within your activities or fragments. The views can point directly to the data model. They can also point directly to a model to perform actions. So you can essentially get your activities and your fragments out of the picture completely and let that interaction happen between your views and your model. I like to think of data binding as like all these pieces of data bound to the views, and so I'm also learning Sketch, so I did this kind of little Andy. I hope you like my graphic. Okay, so let's start up with like a quick intro to getting started. So to enable data binding in your project, in your app modules build.gradle file, there's an Android section, obviously, where you have a lot of configuration. To enable data binding in your project, you just have to add a section for data binding and set it to enabled. This will do everything that you need to make sure that you can start building data-bound applications. And then your views change a bit. So this is a traditional view within Android, right, where you've defined a layout XML file, and your root tag is the view group, the root view group for your user interface. With data binding, the root tag is a layout tag, and it pushes that root tag down. So you'll have a layout tag with exactly 2 tags underneath it, a data tag, which you'll define variables that you'll use within your view to build the view, and then whatever would have been part of your view group there. So in this case, I'm saying, hey, this is a user interface that needs a view model injected into it. We'll cover how that happens in a second, but it's saying that I need a view model of this type to start doing things. And then I'll build out my view, and instead of just setting some default value here, I'll actually reference that view model that was injected in and a property on that view model to build that out. And if my view model follows the right rules, then anytime that data changes, this will be reflected right away in my view without having to do any kind of lookups in my activity or somewhere else in my code and manually changing the text to what the new value should be. I can also then tie basically actions, like let's say this button was clicked, I can tie that directly back to my view model. If you're wanting to introduce data binding into an existing project, once you've enabled it in your build.gradle file, the cool thing is Android Studio is really good about making it easy to convert your existing views into data-bound views. So all you have to do is open up an existing layout once you've enabled data binding, and hover over the root view. And then there's a little quick assist light bulb that comes up here. If you click that, you can click on this option to convert to a data binding layout. And what that'll do is it'll push that root tag down in here to your kind of root view group for your user interface. And it'll add an empty data tag and put all this together. And then you can just add your own view models or whatever variables you're putting in here and use that to build out the rest of it, replacing all of your existing text stuff with these expressions. So for the simplest example, the first project that you'll see, and I'll pull the code up here in a second, is a very simple counter. It has a label text view that's just displaying the value of this count property at any given time. And anytime we hit the plus or minus button here, it's going to fire off an action that's going to update this data. And when the underlying data changes, it's going to update this label right away. So let me go ahead and show you that real quick so you can kind of get a feel of what you can expect when you check out the code. So the project has all four of these applications as separate modules. So if you just clone the root project, you'll see that you have four modules here. There's this counter, which we're about to show, and then there's all the others that we'll get to through the deck. So this one, for example, if I launch it, you'll see the sample. You can check it out when you get home or whatnot. Pretty basic, but this is like bare bones, like what everybody starts with. Notice that I lose state when I rotate. We're going to change that later using the architecture components view models, but that's essentially the basic example. One thing I wanted to point out here too is as I'm defining my layout, when you start using data binding, you'll find yourself using these tools attributes a lot. So what these tools attributes do is it tells you at design time what this is going to look like. Because typically, when I'm building an app that's using like just an MVC pattern or an MVP pattern without data binding, I'll just set my text here to say like 0, but then what I would do is, since I've defined an ID, somewhere in my code, when I'm rendering my view, I'll go find this text view by ID, and then I'll manually set the text. But since I'm binding it directly to data that doesn't exist right now, if I don't have this, that goes away completely. Not only does it go away completely, but it no longer takes up any space, so it looks like those buttons are going to crash in. And if I'm not highlighted on that particular text view widget, I can't even tell that that was there. So it's very important that as you start building out your user interface, if you're using data binding, always make use of these tools attributes. And they have basically everything that your Android one would have. So if I looked here for like Android layout margin, there's a, sorry, new MacBooks. There is a tools version of it. And the code assist is great. So start typing layout. So I can basically define all the same things that I could with my Android attributes with the tools. OK, let's go back to slides. So let's talk through this simple example. So if you look at the layout for this counter, the first thing it does is it defines this variable that it's going to use to populate its view. Inside here, I have a constraint layout. And inside that constraint layout, I have 3 views that are bound to some sort of data or actions. In the case of the counter, it's just a label, basically, that's bound to this view models count property. And anytime that changes, it's going to reevaluate this expression and basically update the value of that text view. Now I'm doing this string.value of because since count is an int, text, if it finds an int, will obviously think it's some sort of resource instead of a literal string. For my increment and decrement buttons, they're just firing off an action directly on the view model. And what's cool is the view model, which is this in this case, is literally this simple. Like there's nothing tying it to the Android lifecycle. It's very easy to test this. It's very succinct, really. It just has a single property, and this property is following Java conventions for being a property with a proper getter setter. To make this bindable in the sense that our view will observe it, we annotate it with this bindable annotation. And by annotating it with this bindable annotation, that creates a binding field, this br.count. It's just like you'd have resources, but here you have binding resources. This got generated as soon as I added this bindable annotation. And so when somebody clicks increment, it sets the count to whatever the current count was plus 1. In setting that count, it changes the property and notifies listeners like our view that that property's changed, and then our view responds to that. All this works because I've extended a base class called a base observable, which is included by the Android data binding library. The last piece to tie all this together is to, when I inflate the view in onCreate, I also create what in this case is called an activity counter binding. It's basically a binding class that you get when you use this static function called setContentViewOnData binding util. So it's a little bit different than our normal setContentView. What this does is it creates this binding class that was a class generated by your layout file. And once you have that, you can do things like set the view model, right? And in this case, we're setting a view model. That setter shows up there because we've defined a variable called view model that we need. So if we change this view model name, we would change the setter name. So that's how those kind of line up. Also, this defines the type that we need to have. And so this, we can pass in the type here. You can use parameterized types too. It's a little bit not as pretty because since this is all XML, you have to use like ampersand, LT, semicolon, and then the greater than, but that's still an option. I mentioned this before, but to me, the best thing about using like a view model along with data binding is your view model, you can really test all the presentation logic or most of the presentation logic without having to worry about mocking the view in any way, right? So there's no view to mock out. There's nothing with the activity lifecycle that we care about. With our tests, we can just verify that when we click the increment button, i.e. call the increment method, that the new value of that variable is what we expect. Okay, so let's take a closer look at some of the things that I kind of glossed over for that simple example. I want to talk about the data tag. So the data tag doesn't have to have a single variable, and it doesn't have to be a view model or implement-based observable. But this is just defining any variables of data, even plain old Java objects that you want to use to compose your view. The advantage to making base observables, to defining base observables that come in here, is that you can change those values after the view's been rendered. If it doesn't implement an observable or base observable, then it'll only work the first time the view's loaded. You can also do a lot of imports. So a lot of times in your view, you'll want to set some visibility with an expression. So you'll check some condition to see if it's true or false. And if it's true, you'll set maybe the view to visible, else you'll say view.gone or view.invisible. So to be able to do that and reference these static fields, you have to import that type. But you can also do it with your own type. So if you want to import some utils class from your application, you can certainly do that here. Just import the type would be, maybe in this case, com.acme.stringutils, and then you can use that down below in an expression. The expressions themselves start with that @ syntax and open close curly brace with single or double ticks. I personally like to use single ticks because then if you're calling a method later, you can use double ticks, and it kind of works out. You can't use the reverse, so if you had the attribute of the expression with double ticks, you can't use single ticks on the inside. So it's a very minor thing, but just preference. You can call any static methods. You can call any static values. You can reference any of your resources. So if you have a string or if you have plurals strings, right? Any kind of strings that take arguments and produce a result that's based on some sort of templated text plus arguments you passed in, you can do that here. One of the examples you'll see, I reference a drawable and pass that in. So you have a lot of freedom and flexibility with these expressions. The way that expressions evaluate properties, so if you read this and it's setting, let's say, a value to a text field, this is viewModel.value, but value is looked at as a property. And how the data binding framework goes about resolving this is it'll first look at getValue to see if you've made a real Java property with the method getValue here. If it can't find that, it'll go down and find value, open, close, paren. And if it can't find that, it'll look for a public property. So if you're building out any sort of backing variable for your layouts, it's probably a bad idea to kind of mix and match these because you'll end up shadowing the others. So if you have all three of these, it'll find this one every time. If you take that one out, it'll find this one, et cetera. So just be careful with that. The expressions are entirely null safe. So this expression, no matter if any of these are null, that's OK. So if viewModel's null, you won't throw a null pointer. Same thing with value or subvalue. If you want, you can coalesce it to a default value. So if any of these were null and this whole expression turned out to be null, then you can default it to returning that as the value when this expression is evaluated. OK, so that's everything for the data expressions. That's mostly our view layer. Now I want to talk about how we can make data observable. So in our example, we extended this base observable view class, which you see here. And that implements observable. It's included by the data binding framework, so it's very easy to use and get started. It gives you a few things like you've seen with notify if properties changed, that this specifics properties changed. It also gives you this notify change. So this would be useful if you have a variable that you're using to populate your UI and you have a lot of properties that might change on it, like say half a dozen, and you're updating them frequently in some sort of action call. It's probably a better idea to do one notify change after you've updated all of those properties so that you don't spam your view and binding with all those updates. Through experience in a production app that I was working on for a different company, we found that if we didn't wait till all these properties had changed and then send one notification, if we just kept spamming it with a lot of notify change for this property, that property in a loop, sometimes it would actually drop notifications. All of those notifications don't fire right away. They're dropped on a queue to asynchronously fire, so it's something to consider. If you don't want to use the base observable class because you have your own base class, no problem. You could implement the observable interface. You just have to provide a way for the data binding framework to add property change listeners, because that's how those fields get updated. When you're using the data binding stuff and you have an observable that you're observing the value of, the data binding framework will add callbacks and remove them. So in this case, for example, if you wanted to, say, extend a view model from the Google architecture components, you could do that by extending it and implementing observable, and then just bring down all the base observable pieces and parts that you need to make your view models observable. And I did that in the examples, so you'll see that replicated across a few of the examples. And then what I did is instead of extending base observable, I just extended my observable view model and got around it that way. There are other options too. So you can, for all the primitive types, there are observables for that too. So I could have an observable int here and represent my count as that. And then it doesn't matter what I extend here. I'd still be able to update my view. All this is just a wrapper for the same thing. So underneath the covers, it's doing notify change on its value. And it's also putting that bindable annotation. But it makes it a little easier for simple UIs. Outside of int, there are also ones for all the other wrapper types. There's also an observable array map and an observable array list, which can be kind of nice. Those will fire if any of those individual items change. So if you had an observable array list of 10 items and one of those items changed, only that item would fire, not all of them. So again, I found this used best in smaller, simpler views without a lot of things bound to them or without a lot of action on throwing notifications changed, because again, you don't want to spam the UI trying to keep up with all these notifications. If you have a big group of them, just do them all and do one notify change. One thing I don't see talked about much, but it's totally doable, is you can notify that your properties have changed from a background thread. This isn't synchronous, and when you notify a property changed, it actually makes sure that it's notifying the view at the right time on the main thread. You can read more about it here, but essentially it means that, you know, in a typical application, if we have a background async task thing running, if we want to update our UI at all, we have to jump back to the main thread on another, by some other mechanism. So with this, we don't have to worry about it. From whatever thread we're on, we'll just push the update, and it gets back on the main thread at the right time. So everything I've showed you so far is one-way data binding, and that's all really cool, but they also offer two-way data binding so that data can get up to your view and then back without any work on the part of your view model or variable. So this was how we did one-way. Two-way, you just add an equal sign between the @ sign and the curly bracket. So in this case, you'll see another app that I have in our examples that builds a simple login form. And I pre-populate the username with whatever the last user was to log in. So when you log in, you click this button, it saves off that user in shared preferences. When the apps launch next time, it brings that up and it pre-populates that in the view model. The layout in this case reads that value, but since it has this @ equals, it's also changing that value. So in our view model, these are just defined as variables, and because I don't care, once I populate the view the first time, I don't really care to re-update the view from what's happening on the view model side, so I don't even need the bindable stuff or anything. So I just populate these when the view first starts up, and then when login's clicked, it can just use these variables. It doesn't have to go refetch the current value from the views, because it just has them. These are just live updating from the views. So that's kind of a nice feature. There's some other stuff that I did with this app that we'll come back to with LiveData. How many people have used data binding here, by the way? OK, so a few. Of those who have used it, how many have used binding adapters? OK, so a fair amount. Binding adapters are these really cool things that allow you to, and I ask because I didn't initially, when I first started using data binding, it took me a while before I started using binding adapters. But once you use them, they're really convenient. They basically allow you to add any custom attribute to any of your views. So let's say, for example, I wanted to I wanted to set up an image view that pulls down an image from some other website somewhere, right? And I wanted to populate that in my image view, right? But you don't want to do that synchronously, and frequently you'd use something like Picasso or Glide or some other framework to kind of go out there, download it off the main thread, then load it into your image view. What you can do, though, is define a binding adapter on a static method, and within that binding adapter, you define an attribute here, and whenever you're doing this and you're defining a new attribute, you should always use like the app namespace, or at least in my experience. So you do app, in this case, like image URL, and then you can use that inside of your views. When you're building out your views, you can add an app image URL attribute, and then you define an expression in here which evaluates to a string, and then you can actually process and show it, download the image and then show it in your view. So the way this works is we know that this applies to an image view because the first argument is an image view. So if you wanted this to apply to all views, all you'd have to do is just take a view as your first argument. And the cool thing is Android Studio is great about when you go to build this. This won't build because if I add a text view, it knows that that doesn't apply to the image view. They're not part of the same hierarchy. So it'll say something along the lines of, hey, I don't know about this image URL attribute for an image view. The type of what this expression needs to be is defined by the type that you pass in here. So when I've defined this binding adapter, it's applying to image views, and now you start looking at like lining up the attributes. So app image URL maps to this string URL, and then so this expression better come out to be a string, or else there's going to be another build time issue. And it also has to be an expression. If it's not an expression here, it'll just disregard it. It'll say, I don't know what an image URL is. So you can add extra arguments too. So this would be like if you wanted to add, say, a placeholder image, you could totally do that. You just add another comma delimited custom attribute here. And again, you follow it down. So image URL is a string, placeholders a drawable. And notice here I'm using that @drawable syntax to pull in a drawable from my resources. You can override system attributes. So if you, for example, anytime in your application you're setting visibility, you might want to maybe log that visibility's changed, or you might want to animate that view going in and out. So there's a great example, a full example on how to do this at medium.com. George Mount, he puts out a lot of great examples. He has one here. If you open my project, you'll see that I also do that, but it's a much more watered down example. But basically, I override the Android visibility attribute so that anywhere you use that in the application, as long as you pass an expression to it, it will animate whatever it is you're making go invisible. It'll make it kind of fade out, and when it becomes visible, it'll fade in. So when you get to this kitchen sink example and you're on even numbers, you'll notice this label kind of comes in, and on odd numbers, it goes out. Converters are another potentially useful thing. I haven't actually used binding conversion in practice. If anybody has, I'd be interested to talk to you afterwards. The idea of it, though, is kind of neat. You can, let's say you have an attribute like visibility that expects an int, right? It's expecting one of these constants to come through here. But typically, what we're really doing is testing some sort of Boolean expression to see if it should be visible or not. So rather than having to test it and then pass in the right int, you can write a binding conversion that says that, hey, anytime there's an attribute that is receiving an expression that results in a Boolean, but that attribute expects an int, apply this function. Does that make sense? OK. It's kind of neat. The only thing to kind of be careful about here is now that I've defined this, I'm saying this applies across the board everywhere. So any attribute that is expecting an int and receives a Boolean, and it's done with an expression like this, will apply this function. And that might not make sense for everything, right? So you should do this with caution. Another concept that you might be wondering about if you haven't used data binding is how does this work with recycler views? Because in the examples that I've shown you, I've done everything in the activity on create. With a recycler view, we obviously have these recycler view adapters. It's honestly not that much different, and I have a simple example here too. The biggest difference is instead of just inflating your view and passing that to your view holder, you create a binding just like you would have in your activity, and you pass that binding to our view holder. And then when onBind view holder gets invoked, you get the item just like you normally would. And when you bind that, instead of coming in here at the bottom and based on views that you found by ID, setting their text values or their visibility, et cetera, you just set the variable just like you would have before. So in this case, my layout must have defined a variable named item view model. And so I set that in here, and then you have to call execute bindings. The reason for this is if you don't call that, and for some reason some of the data changes some of the dimensions of the widgets, like your text views and whatnot, your geometry will be off. So if you call execute bindings, it executes this right away, and you get basically the right sized view elements. All right, so that covers kind of like everything I've done in a production sense. Now, since a lot of my experience in data binding. Since then, LiveData and a bunch of the architecture components come out. So I've recently been trying to figure out what's a great way to use LiveData with data binding applications. So I haven't shipped any of this. This is mostly based on just kind of trying things out. But I think that, I don't know, I found some of this stuff useful, and I hope that you do too. I'm using LiveData a lot nowadays to manage state. So in this case, if you think about a typical login screen, the first thing you are is in a state of waiting for a user. The next thing is attempting a login. So you type in username and password, then you click connect, then you're going to be in attempting login. And then either that's going to be an error and you're back to waiting a user, or it's going to be successful and you're authenticated. So what I've done in the example, when you pull it up, I've created a view model that also uses that two-way binding, but it also manages the state through this mutable live data. And so when you attempt the login by clicking that action, it changes the state to attempting login, and the activity you'll see is bound to that and shows a progress dialog when it's supposed to. And once you've logged in, if you're successful, it hides it and would move to the next activity. Or if it's a failure, it hides it and shows the error. So the way that looks on the activity side is it's observing this, view model's login state. And anytime that changes, if it's waiting user, like I mentioned, it hides the progress indicator because it's waiting on the user to type. If they're attempting login, it'll show it, and we'll move into unsuccessful. Same thing with the error. So if there's an error and the error's not empty, we just pop that error up. So I want to kind of show you that in action, and then talk a little bit more about the code too. So that's going to be the login form example. And the other cool thing about this too, once it comes up, I was talking with somebody yesterday here at the conference about what would happen on rotation. Am I going to lose the fact that I'm still trying to log in? And using this method, it actually just all still works out. So let me put in some bogus password. It's going to attempt to log in. It's not really hitting any service. I'm just simulating all this. Let me change the login service to something a little bit longer so that we can kind of see how this works. So by the way, for my login service, it's just like sleeping for, in this case, it'll be 7 seconds in the background, then coming back to the main thread and saying either success or failure. Okay, so let me go ahead and type in good. So this is going to take 7 seconds to complete. And so you'll notice that I can rotate, and all this still works. Everything's disabled until the process is completed. So you can check this out more on your own. The only other thing I wanted to point out with this example too, though, since I have it up, if you look at the code, you'll notice that I am still referencing the view of login button. And one thing I wanted to point out is just because you're using data binding doesn't mean you have to like fully drink the Kool-Aid and use it for everything everywhere. There's a lot of cases where it might make sense to still reference a view within your activity. If you're going to do that though, just give it an ID and grab it from the binding itself. So data binding, for any elements that you give an ID, while it's not required, if you do, it automatically has a reference to those. So when you've created your binding inside of onCreate, you can get a hold of any views with IDs that are data bound here. So I don't have to do a find view by ID, and that's much more efficient. I chose to bring it in this case because whenever I'm hiding or showing a progress dialog, I also disable the login button, and I felt like that should be one succinct unit of work rather than having my view do that separately. So I'm going to leave you with a few tips. I think I'm getting short on time here. Avoid adding logic to your expressions, even simple ternary ones. What I've found is that as we start doing that, it's very hard for us to know what's going on in our view. You can't test it, right? You can't test this, especially unless it's like an espresso test, but you can't unit test this. It's also hard for new developers. Like new developers that came on our team, initially we had a lot of this stuff. And it was very hard for them to understand what was going on because most of the presentation logic was in a view model, and then they had this extra bit here, right? And it was just hard to follow. Same thing for on click, like never do something like this, like canceling a click if some condition's not true. I only say this because we initially did some of this stuff and it never turned out well. At least in my experience, data binding with MVVM works really well. It's not to say that you can't use it with MVP or some other patterns, but in my experience, it works really well, mostly from the testing aspect. I said this a little bit, but I can't stress it enough. Make heavy, heavy, heavy use of your tools attributes, because if you don't, new people will come on to the team, or you'll look at your code a month later, and you won't be able to understand the view at all. It'll just look blank or like a bunch of random things everywhere. So use the tools attributes to make a good representation of what the screen will look like. Custom attributes or binding adapters are great. They can really simplify things, so definitely use them as often as possible. And the last kind of tip I want to leave you with is, a lot of times when you're building out your layouts, data binding is awesome. However, the error reporting isn't so awesome, and a lot of times you only see the last error of something, right? So if you have a layout that has 10 different errors, a lot of times you'll only see one of those errors, and you'll fix that one, and then you'll see, you know, the rest of the errors and the rest of the errors. And so it can be very tedious to track these down, and also the language isn't always very good. I mean, it's hard to tell sometimes what exactly the issue is. So as you're building out your layouts, you make a few changes, run it. Does it run? Great. Make a few more changes, run it. And also see tip number 1 of not putting all that additional logic in. A few great resources. There's some really great video talks on Realm's Academy website from various conferences. George Mount is fantastic. So if you go out to his Medium page, he has like these simple little tidbits of how to do all this stuff, like animating your visibility in and out, and a lot of other great things. And of course, I have a couple samples. The one we went through here was this data binding demos. I also did a tic-tac-toe game built with MVVM. You can check out on my GitHub page. And that's all I got. Thanks so much.